Hey everybody. Thanks for tuning in. It is Tuesday evening when I'm recording this. Ideally, you'll be watching this on Thursday during class, as I had told you. Essentially, how this is going to work is I am going to record uh, the entire lesson. So you're basically going to watch the notes part, and then you're going to hit pause. There's going to be a worksheet. Uh, I believe what I've told the proctor is to work on that individually. If once people start finishing, I'm cool if you want to work on that in small groups. And then after you complete the worksheet, I want you to come back to the video and watch the rest of it for the answers. Okay? So again, I'll try to get through the definitions and theorems as quickly as possible. Thanks again in advance for taking notes. And here we go. So as some of you, I think, already figured out, a trapezoid is a quadrilateral with exactly, it's going to be a key word here, one pair of parallel sides. All right. And so if we think about this, there's only one pair of parallel sides. And so this is not a parallelogram, right? This is not a parallelogram, right? A parallelogram would need to have both pairs of parallel sides. Or the next one, uh, we've talked a lot about bases, right, as being like parts of figures. So for a trapezoid, we say that the parallel sides are the bases, and the other sides, which I'll talk a little bit more in a second, the other sides are called the legs. So again, trapezoids have exactly one pair of parallel sides. They're not parallelograms. The parallel sides are the bases, the other sides are the legs. If we come on down here, we take a look at these trapezoids. I suppose it might be kind of obvious which one it is based on how I've drawn the pictures. But again, notice that 140 and 40 add to 180, 180 add to 180. So the point being is that we have that these angles, the same side interior angles are supplementary. So we have these two parallel sides. So these are the bases right there, the parallel sides. And these are the legs, which are the non-parallel sides. Over here, again, you could just add up 90, 90 and get 180, 70, 110 and get 180. Of course, it's always nice to go back to our theorem from earlier that says two lines perpendicular, right? Two lines perpendicular to the same line are parallel to one another. Of course, you have to say in a plane before you can use that theorem. So in this case, actually, these guys are the bases, right? These guys are the bases. And these guys are the legs. All right, so the point being is that I could rotate the picture. Uh, the point being here is I can rotate the picture. So keep that in mind. Again, the bases are the parallel sides, the other sides are the legs. As some of you probably, again, you probably could have guessed, an isosceles trapezoid, right, is a trapezoid with one pair of parallel sides. One pair of parallel sides. Now, this is important, right? We have a theorem that says that if a quadrilateral has a pair of sides that is both parallel and congruent, right, then that quadrilateral is a parallelogram. So when you're talking about an isosceles trapezoid, you have to say that the congruent sides cannot be parallel. Okay. And in fact, that means that the congruent sides, right, are the legs. All right. So the congruent sides are the legs. Again, if the congruent sides were the bases, well, then we'd have a pair of lines that's both parallel and congruent, which again is one of the 5 ways to show that a quadrilateral is a parallelogram. So that is important. If we scroll on down here again, this is a picture. And again, these are the bases. And these are the legs. And I suppose I should probably mark here that, again, I just said this before, But the point is that if the bases, if the bases were also the congruent sides, then it would be a parallelogram, right? Which we just said trapezoids are not. So you might want to annotate that as to why. All right. So moving along, we're going to have a theorem about isosceles trapezoids. You can probably guess what it is. We're going to say that the base angles of an isosceles trapezoid are congruent. The base angles of an isosceles trapezoid are congruent. In terms of what the theorem looks like, I have trapezoid ABXY, where BX is congruent to AX. You might be wondering, well, hey, what are the base angles? And so we say, and essentially, if you think about it like BX, right, BX is opposite angle Y and AY is opposite angle X. The point is that these two angles are going to be congruent. Angle X is congruent to angle Y. And also, it will turn out that angle B is congruent to angle A. And I'll talk a little bit more about angle B and angle A in a second. But let's first focus on X and Y. So there's a couple of ways to do this. Actually, one way your textbook recommends doing this is using the first theorem from the lesson on parallel lines. So, but that's not, we haven't really touched on that. So I'm going to go in the other direction. And again, you notice here we don't really have any information to work with. So when in doubt, in the unit about quadrilaterals, we spent a lot of time talking about parallelograms. Let's draw a parallelogram. So I'm going to draw this line here to Z. And again, Z is some line, some point not on AY. So there must be, so BZ is going to be that line that's parallel to AY. All right. And I guess maybe I shouldn't quite draw over this because that will be important. And so now if you look at it, right, ABZY is a parallelogram because AB is parallel to ZY, BZ is parallel to AY. And so this quadrilateral is a parallelogram by the definition of a parallelogram. And so if I call these angles 1, 2, and 3, right, I also know, right, that because ABZY is a parallelogram, then AY and BZ are congruent. And maybe I'll move this arrow up here just so you can see it. So AY is going to be congruent to BZ because, again, opposite sides of a parallelogram are congruent. So now I know that angle 1 and angle 2 are congruent. And that is the isotriangle theorem. And then I also know that I have these parallel lines cut by a transversal. So angle 2 is going to be congruent to angle 3 by, again, that's because corresponding angles are congruent. Again, if you were writing out the theorem, you'd have to write the whole thing. But we're just writing the main ideas. And so, of course, 1 and 3 are congruent by transitivity, right? And of course, 1 and 3 are just, if I could spell transitivity, that would be great. Transitivity, there we go. And 1 is the measure of angle X, and 3 is the measure of angle Y. So we've already got that X and Y are congruent. And now the question is, well, let's talk about B and A. And so maybe if I come back up here for a second, right? If you look at it, remember that these pairs of lines are parallel, right? And so if we call this B, A, X, Y, right? That X and B are supplementary and A and Y are supplementary because we have a set of parallel lines cut by a transversal, so same side interior angles are supplementary. And so if B and X are supplementary and A and Y are supplementary and X and Y are congruent, then A and B are congruent because of one of the theorems from way back. It came up on the last test. It's because subs of congruent angles are congruent. So again, if we had to write that out on a test, it's a little bit more intensive. But the point here is just the main idea. So subs of congruent angles are congruent. So again, it turns out that both of the base pairs of angles in an isotrapezoid are congruent. This is actually not, this doesn't have a name, but in tomorrow's class, I have a theorem or a proof where you'll work through this a little bit more intensely. Today, it'll be more just for the algebra type problems. The next thing we're going to talk about is the median of a trapezoid. So in our last unit, right, we had medians of triangles. They were drawn from one corner to the midpoint of another side. In this case, you might have guessed, right, that MN, right, is going to be, if MN is a median of trapezoid SR QP, then it's going to split both of the sides congruently. So the median of a trapezoid is a segment that joins the midpoints of the legs. And we had quite a few theorems back on January 8th with theorems involving parallel lines with segments joining the midpoints. In that case, it was a triangle. Here it will be a trapezoid, but like I told you back then, that those theorems seemed a little bit out of place at the time, but we're going to use them both in the proofs here, and then you'll see how to link them all together on the worksheet. So our theorem, as you guessed, right, the median of a trapezoid is both parallel to the two bases, and it has a length equal to the average of the bases. So I'll give you a second to write that down. The median of a trapezoid is parallel to the bases, and it has length equal to the average of the bases. And again, we're going to use those theorems from January 8th, which again felt a little bit out of place at the time. But I hopefully you will see their relationship. It's going to be kind of cool. So you can write that down. I'm going to move on. If you need to write that down, pause it. So I'm telling you that trapezoid PQRS has median MN. All right, and I've left the proof statement blank because I want to make sure we know what's going on. So maybe pause the video, look back at the theorem, and try to figure out what the proof statement is. Assuming you've now done that. Again, we want to say that MN is parallel to PQ, and MN is parallel to SR. Right. So I feel like that's number one, and then number two, we want to say that MN is equal to 1/2 of SR plus PQ. Again, that's the average. We add them up and divide by 2. And so if you look at the textbook, there's a bunch of ways to do this. I'm going to try to make our new thing look kind of like our old thing from January 8th. And so I'm going to draw this auxiliary line here. All right, I'm going to draw this auxiliary line here. I'm going to call this point T. And so if you look, right, SM and MP are congruent. Maybe I'll only make one tick mark because again, MN is a median. And so SM is congruent to MP and RN is congruent to NQ. All right, so we've got that. And we also know that SR is parallel to PQ. So again, I suppose that I would have to tell you, well, I guess because we know the median is coming from the legs. Again, in terms of what a proof looks like with trapezoids, you'll see that a little bit more tomorrow. But for right now, this is what our picture looks like. And we would first really like to show that triangle SRN is congruent to triangle TQN. TQN. And if you look, we've got a pair of corresponding sides, right, RN and QN. And then we've got this pair of vertical angles here, right? So angle SNR is congruent to angle QNT. And then because we have these parallel lines, so I don't make this more confusing, we've got these parallel lines. Maybe I will use a different color here. So we've got these parallel lines here, right? SR and QT, and they're joined by this transversal. So now we've got these alternate interior angles. I'll give those 2 tick marks. So we've got 2 pairs of congruent angles, right? The vertical angles and the alternate interior angles, RN and QN are congruent. So these guys are actually congruent by angle, angle, side. All right, and that means two things for us. The first one, well, I guess I guess for right now, it really only means one thing. So it means that Sn the is equal to Nt. And I'm going to use the length. And you'll see why in a second. But the point, right, is that the length of segment Sn is equal to the length of segment Nt, and that's, of course, by CPCTC. And so now I'm going to zoom in again, and I know that these two guys are congruent. And if I take my, I'm going to use blue, and if you look at this image, right, if you look at this image, we have this triangle, SPT, and MN is going to be drawn to is going to join the midpoints of two sides, right? SP and also ST. And so because MN joins the midpoints of two sides of a triangle, we have a theorem, the last theorem from January 8th, that says that MN is going to be parallel to PT. It's going to be parallel to PT, and it's also going to be half the length of PT. Okay, and that's by the last theorem from theorems involving parallel lines. So MN is parallel to PT, and the length of MN is equal to half of PT by the last theorem from theorems involving parallel lines. And if MN is parallel to PT, well, then it's also parallel to PQ. So essentially parts of congruent lines are congruent to each other. I'm not going to, again, we'll see some good questions similar to that with proofs. I'm not going to get too carried away with that. So the point is, if MN is parallel to PT, it's also parallel to PQ, which is a part of PT. And then if MN is parallel to PQ and SR is parallel to PQ, then MN is also parallel to SR because we have a theorem from Unit 3 that says that two lines parallel to the same line are parallel to one another. So we can check off number 1, right? We've gotten both of these. Let's look at MN is equal to 1/2 of PT. So if I look at PT, I can rewrite it as PQ plus QT using the segment addition postulate. So MN is equal to 1/2 PQ plus QT. Again, that's segment addition postulate. And now if we scroll back up, we know that QT is congruent to SR, right? Because those two triangles were congruent. We know that QT is congruent to SR by CPCTC. And so now we can go and substitute in SR for QT. And so MN is equal to 1/2 of PQ plus SR, and that is by CPCTC / substitution. I did that all in one just to save you some time and space. So again, the theorem is actually, I think, pretty simple. You'll get the hang of it pretty quickly. But these theorems are going to show up in the worksheet. And so make sure the theorem is from theorems involving parallel lines. So the point is that I think this is a good refresher on that and something that should help you on the worksheet. At this point, you should pause the video, go get the worksheet. I don't know if your proctor will hand it out to you or you'll go get it from them. And again, work on it. If you have, as people start to finish the video, I think it would be great if people could work in small groups and then come back to the video to check your answers. So again, pause the video, get the worksheet, and then come back. So again, hopefully you've paused the video and checked out given the worksheet a shot. I think some of these questions are pretty straightforward, but there's some pretty good ones on here too. So for the first one, we've got a trapezoid and its median. So we know that a trapezoid the median is half, or the average of the two bases. So here, x is going to be equal to 1/2 of 25 plus 13. Of course, 25 and 13 add to 38, so 1/2 of 38 is equal to 19. The next one's a little bit more interesting. So 10 is equal to half of 2x minus 4 plus x minus 3. And so what I probably recommend you do here is multiply by 2 on both sides. So 20 is equal to 2x minus 4 plus x minus 3. And now we get that 20 is equal to 3x minus 7. So 27 is equal to 3x. So x is equal to 9. Again, I think setting up the equation is the most important part there. I usually recommend you multiply by 2 just to make your lives a little bit easier, depending on what those, because you probably don't want to have 3x and -7, right? If we keep going, number 2 looks pretty similar actually to, again, those diagrams from theorems involving parallel lines. I'm going to say that, I guess, 10 more times. So I know that HJ, JI, and IH join the midpoints of the segments. So I know that these two segments are congruent, these two segments are congruent, and these two segments are congruent. But in actuality, right, if KL and ML are both 16, right, then these are both 8. These are both 8. And so we also know that JI is a segment that joins the midpoints of two segments. So it is going to be parallel to the base. It's parallel to the base. So if we look at MJIK, trapezoid, MJIK is isosceles. Because, again, it has a pair of congruent legs and the bases are parallel. And then to find JI, we can use the second part of that theorem that says that that parallel line, JI, is half the length of MK. So JI is going to be 6. And so to find the perimeter, we're going to do 8 plus 8 plus 6 plus 12. And when I did that, I got 34. So 34. Okay, so again, we're combining our theorems about trapezoids and from the last class. For the next one, hopefully my hint here allowed you, maybe hopefully weren't arguing with your neighbor too much about this. The point is really just how you organize it. So if I have T, U, N, E, I drew it like this. And so if measure of angle T is 62 degrees, well, then T and U are congruent. And then I know that E and T are same side supplementary. So we need 118 degrees to get to 180. And then again, E and N are congruent. So 118. Or if you went the other way, T, U, and E, same idea, right? 62 degrees, 118 and 118. So the point is just make sure you are clear in how you draw the picture. Again, I should add these. For the next one, this is really the next page is where it gets a little bit more real, I think. So here we have a picture that looks familiar to us, right? We have those triangles cut by where the segment joins the midpoints of two sides. But if you look at ADFC, that's a trapezoid with a median. So that's where it gets really interesting. So if we look at AD and BE, we're looking at this triangle. And we know that because AD joins the midpoints of those two segments, that AD is going to be half of BE. And I probably want to simplify that a little bit to say that BE is equal to double AD. All right. So now if AD is equal to 7, I want to find BE and CF. So let's find BE first. I can use part A, right? So BE is equal to 2 times 7, which is going to be 14. And now what happens is that I've got to figure out what CF is. And so BE, again, is the median of trapezoid ADFC. And so maybe I'll mark that up in blue, right? BE is the median, and I know that the median of a trapezoid is 1/2. In this case, it's going to be AD. It's going to be AD plus CF. All right. And so what I can do here is, and of course AD, and maybe I'll just erase this. So AD, we just found, we know AD is 7, right? We know AD is 7, and we know that BE is 14. We just figured that out. So if I multiply by 2 on both sides of this equation, I get that 28 is equal to 7 plus CF. So CF is equal to 21. CF is equal to 21. If we look at question C, if AD is equal to X and BE is equal to X plus 6, let's find X. So again, we can go back and use that first equation, linking BE and AD. So X plus 6 is going to be 2 times X is going to be 2 times X. So what I'm going to do here is I'm going to subtract X from both sides. And so X is equal to 5. X is equal to 5. Okay, I have it in my... Sorry, X is equal to 6. Sorry, X is equal to 6. I have it in my notes that it's something else. Well, I wasn't entirely confident myself, but pretty sure the algebra is correct there. For question D, D is hard, or not hard, but this is where I think it gets, again, legit. We want to set up 2 equations. So the first one, let's link AD and BE. And so if we know, again, that BE is double AD. So I'm going to set up that 20 is equal to 2 times AD, which is X plus Y. And so I can actually say that 20 is equal to, I guess even before I do that, I could distribute, or I can just divide by 2 right off the bat. So 10 is equal to X plus Y. And so I've got this, I have one equation and 2 variables. Let's see what happens with the other one. I know that BE is going to be half, right? The average of the other two. So 20 is equal to 1/2 of AD, which is X plus Y, plus 4X minus Y. And something really nice happens here. Again, if I double both sides, I get that 40 is equal to X plus Y plus 4X minus Y. And so the X's cancel. So I get 40 is equal to 5X, which means that X is going to be equal to 8. And so in that case, actually, you don't need a system of equations now that X is equal to 8. Well, Y has to be equal to 2. One quick comment. I believe it's the last question on the homework, number 19. Number 19, so if you look at 19, in the homework tonight, the textbook does mention something, a fact that might be helpful. So, and you may have already picked it up, so I'll kind of allude to it here. So if we know that BE is equal to 2AD, and we know that BE is equal to 1/2 of AD plus CF, we can double both sides. So 2BE is equal to AD plus CF. But again, I know that BE is 2AD, so I can go and substitute this. And so I get 4AD is equal to AD plus CF. And so 3AD is equal to CF. All right, so it turns out that actually that bottom, the larger, I guess, base of the trapezoid is going to be triple the smaller base of the trapezoid when it's joined by a median, when there's a median, which again I think is kind of cool. So again, that might help you on the last homework question tonight. You don't have to like memorize that fact, but if you want to use it, great. I really like number 5. I really like number 5. If we look here, ABCD is a trapezoid, MN is a median. If DC is equal to 6 and AB is equal to 16, we want to find ME, Fn, and Ef. And I said that in addition to thinking about the medium of a trapezoid, you should also consider our theorems involving parallel lines. If that didn't help you, that's okay. I wouldn't be shocked. Let's start off by figuring out what Mn is, right? So Mn is the median, so it's 1/2 of 6 plus 16. So 1/2 of 22 is 11. But the problem is we have 3 parts of Mn. And I would ask that you look here at this triangle, right? Mn is parallel to both of the bases, right? So that little part Me is going to be parallel to DC, and it's also going to be drawn from the midpoint of one side. And so we know that if this line ME is drawn from the midpoint of one side, then it is going to be and it's parallel to the other side, right? Well, now we know that AE and EC are congruent. So we know that E is a midpoint. And we now know that ME is going to join the midpoints of two sides. And so it will be half the length of DC. So ME, if it lets me write, ME is equal to 1/2 of 6. So ME is going to be 1/2 of 6. If you draw this picture over here, you get the exact same thing. Again, we have this parallel line here. It's going to join these two midpoints, and so it's going to split up DF and BF congruently. So F is a midpoint, and so BC is going to be 1/2 of 6 as well. And again, those are going back to our theorems from before. And so if ME is 3 and NF is 3, then EF, right, has to be 5 because there's only 5 left over. All right. So again, I really like this lesson because it's combining two things. I don't think there's anything quite as hard as number 5 on the homework, but it will be on the test and the review sheet. So take a look at that. We'll review on Monday when I come back. I'll make sure we come back to this topic. In terms of looking ahead, you have textbook homework and a quiz on for tomorrow. I know I wasn't here today, but the questions on the worksheet were largely the even problems and you'll do the odd problems for homework. And then ideally, if you're watching this on Thursday, I have posted the review sheet and the answer key for the test next Wednesday. So again, get us started on that. We don't have class on Monday. And so on Tuesday is really your best shot to ask me questions. If you're worried about proofs tomorrow after your quiz on trapezoids, you'll do some proofs with Ms. Chua. All right. Thank you, guys.